देखो, firstly make sure the screen is visible to you all and I'm audible to everyone. Okay, please make sure of that. Very good. Okay, so maybe this would be the second last lecture of this gravitational chapter, and इसके बाद after your Deepavali vacation we will do a little bit of problem solving on gravitation, because यहाँ से question आना ही आना है in either of the examination. If you are preparing for JEE main and you are preparing for NEET, for both the examination, this is a, I think I have told in a 12th class session that these types of chapter is like energy capsules to us. Okay, so these energy capsules is like they are very small in size but gives you everlasting energy, okay, enthusiasm, and make your day. So these types of chapter categorize into the energy capsules. Okay, I would like to say them as energy capsules. Okay, clear है? चलो. So what is the learning objective of today's class? First of all, so we will discuss about the gravitational potential energy first of all. कि this is the core concept of this gravitational chapter. ठीक है? We have also talked about gravitational potential energy in work energy and power chapter. You have learned about it, and in most of the time we are using it as delta U is equals to mgh. ठीक है? So that is why this kind of expression is not so much elaborative, and it can't give you an overview of conservative forces, because you know कि gravitational forces is 1 by r square, showing the proportionality 1 by r square. But in this formula, if you will see, it is not related to r. Okay, clear? So we will see a more derived, more elaborative expression of gravitational potential energy concept wise. Then the very important concept of today's class is escape velocity also. Okay, suppose you don't want to live on earth, you want to go on Mars, or you want to go in space. So if you are interested in that, this topic is for you guys, escape velocity. Then gravitational potential, if you want to apply the gravitational potential energy into effect, you must aware about the gravitational potential. Okay, then continuous mass distribution is a very halwa type of topic. Okay, very easy and very easy peasy topics. So do not need to worry about it. Let's just get started with gravitational potential energy. So I would like you to note down these two things. First of all, potential energy, potential energy of a system is, make sure the ink is visible to all of you. So potential energy of a system is the energy of, is the energy of configuration of system. In very simple word, if I say you, it tells us about that how a system is arranged in space. Okay, very good question, thank you. It also tells us about the potential energy. Just tell you about, I want you to give a feel of it, okay, to you guys, what is actually the potential energy. So potential energy is somehow related to the potential of any object. Okay, potential capacity. Potential means capacity, how capable a system is. Okay, if you want to move such a system, if you want to change the position of that particular system, so you are working against the capacity of the system. Everyone agree on that page? Yes and no? Okay. If you want to move that particular object, or if you want to change the configuration of object, without giving it an acceleration. ठीक है, without giving it an acceleration, zero acceleration. ठीक है, you are moving the object like this with very small pace. So are you not messing up with the capacity or the potential of the object? Got it? Suppose you have a stone you have thrown on the first floor. By you are on the first floor of your house and you throw the stone on the ground, and you have a impactometer, a imaginary device which measures the impact of that particular stone. Okay, so you fold you just drop down that particular object, that stone, and you measure the impactometer. Says impactometer is saying 100, whatever is the unit of 100, it's showing 100. You go to your 10th floor in your building, and then you just drop that object, that particular stone. The impact would be greater than 100 or less than 100? Yes and no. Is it be greater or less than? If you take the same stone to the 10th floor and then you drop it, would the impact of that particular stone will increase or decrease? What do you say? I say that it would definitely increase. So why it is increasing? Because you are changing the position of that particular object, and you are changing the configuration or position of the system, and that is why the potential energy is being stored in that particular system, more and more potential energy. And when you drop it down, it will convert into kinetic energy. So more the potential energy, more conversion in the kinetic energy, more in the impact. Okay, so that is why potential energy is somehow related to the configuration of the system. Okay, because somehow configuration also decides the potential of the object. Okay, so potential energy of a system is the energy of configuration of system. Okay, suppose this is the particle of mass m1 and this is the particle of mass m2. Okay, we have, this is firstly at r1 distance away from m2. M1 and M2 have initially r1 distance away from each other, and finally they have pushed at a separation of r2. This is m2 right now. So what I tell you, what I'm going to do here is I want to calculate the expression of this gravitational potential energy. So in that case, what I have to do, these two mass particle applying an attraction force to each other. This force is acting like this, according in along the line of contact. Okay. So if you want to disturb the position of this object, you have to apply the force in the opposite direction. What do you say? You do have to apply the force, okay, in the opposite direction. Clear? Suppose at a particular instant, the displacement of this m2 here is r, from r1, from this position to this position. Let's say for any instant, this distance is r. So we want to measure the impact of r to r plus dr, कि इस पर्टिकुलर ऑब्जेक्ट को इतने ग्रेविटेशनल फोर्स के अगेंस्ट r से dr डिस्टेंस पुश करने में व्हाट इज द पोटेंशियल एनर्जी चेंज. ठीक है, क्लियर है? बिकॉज वी नो दैट पोटेंशियल एनर्जी, अब देखो अब समझ में आएगा, ये पोटेंशियल एनर्जी इज डिफाइंड एज is defined as the work done as the negative of work done by a conservative force. ठीक है, कंजर्वेटिव फोर्स. तो कंजर्वेटिव फोर्स इन दोनों के बीच में काम कर ही रहा है, ग्रेविटेशनल एफ जी. ठीक है, एफ जी कौन सा फोर्स होता है? ग्रेविटेशनल फोर्स है, और ग्रेविटेशनल फोर्स कंजर्वेटिव होते हैं इन नेचर. तो पोटेंशियल एनर्जी क्या है कि कंजर्वेटिव फोर्स ने कितना वर्क किया उसका नेगेटिव क्या होता है पोटेंशियल एनर्जी। अब देखो ये नेगेटिव क्यों हो रहा है, क्योंकि यहाँ पे कंजर्वेटिव फोर्स अट्रैक्टिव है, तो इसके ऑपोजिट अगर मैं काम कर रहा हूँ तो मैं तो फोर्स के डायरेक्शन के ऑपोजिट ही काम कर रहा हूँ, तो इसलिए ये नेगेटिव साइन है। ठीक है, सो इफ आई से इट दैट du हियर is equals to minus of dw by conservative force, this should be the very primary equation. ठीक है, now du is equals to, just a second, du is equals to minus dwc को क्या लिख सकते हैं, f of conservative dot dr. ठीक है, okay, if you want to calculate the total energy of it, so we have to integrate it. But firstly, what is the conservative force? What is the force acting between m1 and m2? So that force equals to g m1 m2 upon what is the separation at that instant? That separation is small r, so small r square minus g m1 m2 divided by r square into dr. Okay, g m1 and m2 are fixed quantities, we cannot be changed them. g m1 m2 are constant, 1 upon r square dr. Now u will also be delta u here, du u final minus u initial, I write it in a full pace, it is u final minus u initial is equals to minus g m1 m2, 1 upon r square dr will become what, 1 upon r square dr का integration will become, देखो it is 1 by r square, so we can write it as r raised to the power minus 2 dr. So it is nothing but r raised to the minus 2 plus 1 divided by minus 2 plus 1. So it is coming out to be as minus 1 upon r. Okay, minus 1 upon r. Got it? Now, what should be the limit you should put here? Limit would be r1 to r2. This is r1, this is r2. Because initially they are at a separation of r1 and we have finally separated them by a separation of r2. So limits are r1 to r2. So u final minus u initial is equals to minus g m1 m2 1 upon r1 माइनस 1 अपॉन r2. इसमें किसी को कोई प्रॉब्लम नहीं होनी चाहिए बिकॉज देर इज माइनस इन साइड, सो मैंने उसे फ्लिक कर दिया यहाँ पे, ये होता माइनस 1 अपॉन r2 minus minus 1 upon r1, so that would be plus automatically, so I have written it here directly. So this is the final expression of potential energy, change in potential energy. And always remember, change in potential energy is defined always. Okay, absolute potential energy, although we assume something, then we say, okay, that is the absolute potential energy, but absolute potential energy does not exist. Okay, clear? We only say something about the change. ठीक है, बट यहीं पे मैं एक पॉइंट और करता हूँ कि if r1 इनिशियली दे आर एट ए सेपरेशन ऑफ इंफिनिटी, और इंफिनिटी से मैं इस पर्टिकुलर ऑब्जेक्ट को लेके आ रहा हूँ, इफ r1 इज इक्वल्स टू इंफिनिटी, ओके, देन sorry, particle finally placed at infinity, so r2 is equals to infinity, so we can say that uh, u final minus u initial is equals to minus gm1, sorry, हाँ, माइनस gm1 m2 अपॉन स्मॉल r1, एंड r1 को हम लिख सकते हैं स्मॉल r1 भी। ठीक है, क्लियर? जस्ट गिव मी अ मोमेंट, इसमें मैं एक बारी चेक कर लेता हूँ, बिकॉज देयर विल बी अ कॉन्फ्लिक्ट ऑफ माइनस एंड प्लस हियर, just give me a moment, till then you note it down until here, I'll just letting you know what is the, is there any mistake we have done or not. Okay, Okay, so one mistake that we have done here is putting the value of gravitational force. So देखो, we are separating it from here. ठीक है, we are moving the particle in this direction, so displacement is in this direction, but forces of attraction is acting in the opposite direction. So the angle between them is 180 degree, and that is why this gm1 m2 upon r square dot dr cos theta, theta would be 180, so this minus would vanish out here. ठीक है, क्लियर है? एंड अगेन इफ यू पुट द लिमिट हियर, ये माइनस क्या हो गया, वेनिश आउट हो गया था, तब मेरी जो लिमिट्स आई थी वो 1/r2 माइनस 1/r2, 1/r1 भी लिख सकता हूँ, माइनस 1/r2। ठीक है, अब यहाँ पर अगर आप R1 को इनिशियली, इफ दे आर एट फाइनल, इनिशियली द पोटेंशियल एनर्जी जीरो कंसिडर कर लो इनिशियल पोजीशन पे, तो उसके लिए R1 की वैल्यू क्या होनी चाहिए, इन्फिनिटी। So if the particle is at infinity, first of all, so potential energy at infinity is zero. ठीक है, so this u initial will also become zero. So u final को ही आप absolute potential energy बोल सकते हो, which is minus g m1 m2 upon small r. ठीक है, क्लियर है? अब देखो, इसमें एक पॉइंट और नोट करने की क्या बात है, मैं अभी आपको बताता हूँ दूसरे पेज पे। देखो, ग्रेविटी जो पोटेंशियल एनर्जी है, पोटेंशियल एनर्जी सिंगल पार्टिकल की कभी भी पोटेंशियल एनर्जी एग्जिस्ट नहीं करेगी। ठीक है, पोटेंशियल एनर्जी एग्जिस्ट फॉर अ पेयर ऑफ पार्टिकल। ठीक है, तो सपोज देयर आर n पार्टिकल, इफ देयर आर n particle in the system, कैपिटल n particle, ये नोट कर लेना, बहुत इंपॉर्टेंट है। इफ देयर आर कैपिटल n particle in the system, then total pair of potential energy, total pair of potential energy energy is capital N into capital N minus 1 divided by 2. ठीक है, so suppose we have three particle at the triangle. These are the three particles having mass m1, m2 and m3, and this is a equilateral triangle, so each of the side of length r. So here if I want to write what is the potential energy of this particular system containing three charge particle, three mass particle at the vertices of a triangle, so here if you will see, there is a pair of m1 and m2, then m2 m3, and then m3 m2, m3 m2. So this is m1 m2, m2 m3 plus m3 m2, sorry, m3 m1. ठीक है, 2 3 and 3 2 will be same. ठीक है, so here the particle is coming out as 3, so put the value of n. देखो नंबर ऑफ पार्टिकल्स कितने हैं, 3 पार्टिकल है, तो n की जगह पे 3 पुट करो, 3 into 3 minus 1 divided by 2, this will cancel out, coming out as 3. For 4 particle, if the particles are situated at the rectangle or a square, so number of particles are 4, either it is a square or rectangle, 4 particles is there, so n is kitna, 4, so number of pair will be, tell me in the chat box, number of pair, n into n minus 1 by 2, which is 4 into 3 by 2, 2 3 is a 6. So total 6 pair of kinetic energy will be, sorry, potential energy will be there. One is for this, one is for this, one is for this, and then two diagonal. ठीक है, क्लियर है? किसी को कोई डाउट है इसमें? Any doubt guys? If you want to note it down, please note it down. yes and no, any doubt? एटलीस्ट बताओ तो यार. ठीक है. इफ यू हैव एनी काइंड ऑफ डाउट यू कैन आस्क. ठीक है. नाउ. ओके रोशन, थैंक यू. एस्केप वेलोसिटी. देखो, एस्केप वेलोसिटी का कॉन्सेप्ट पोटेंशियल एनर्जी से ही अराइज हुआ है. ठीक है. कंजर्वेशन ऑफ मैकेनिकल एनर्जी से. इट इज एप्लीकेबल फॉर 3D अरेंजमेंट्स. इट एप्लीकेबल फॉर ऑल द अरेंजमेंट्स. ठीक है. इट ओनली डिपेंड्स ऑन नंबर ऑफ पार्टिकल. क्लियर है. एंड हु हैव आस्क्ड दिस ब्यूटीफुल डाउट? वेरी गुड, Mahesh Babu. Very good, Mahesh. So it is applicable for, it is independent of the nature of symmetry or nature of uh, planarity. If it is a planar object, if it is a 3D object, it depends only on the number of particles. ठीक है. If you have a number of particles 4, then pair will be n into n minus 1 by 2. 6, I haven't mentioned that distance would be same or there should be a geometrical issues there. No. So it is independent of that. Now we will have a look on this escape velocity. देखो, escape का अपने मतलब, अपने आप में ही क्या मतलब होता है? escape माने बच जाना, निकल जाना, भाग जाना. ठीक है. सो escape velocity का भी यही मतलब है. अगर मेरे पास अर्थ है, if I have the earth and if I want to throw a particle in such a way that it would never return back to the earth, then that particular velocity I give at the time of throw, that velocity is escape velocity. Very simple. So if you have a friend that you don't like in your class, just throw him away with the escape velocity and you will never see that again. Okay. That particular person, that particular object or teacher or device or anything. Okay. So give them escape velocity throughout the earth's surface, above the earth's surface, and you will never see their faces again. Okay. So it is the minimum velocity. इससे ऊपर ऊपर तो जाएगा ही जाएगा, but it is the minimum requirement. It is the minimum velocity with which a body should be projected from the surface of a planet so as to reach infinity. So the total mechanical energy remains conserved. ठीक है. Let's say a particle or a ball is at h height away above the Earth's surface. This is the Earth. The radius of the Earth is capital RE. Okay, mass of the Earth is M. Clear? So this particle gives a certain velocity in the horizontal direction, and later you will see that it is independent of the direction also, independent of the angle also. Okay. So the concept here is the total mechanical energy remains conserved. Initially, when we throwing it, we are giving it some energy. We are giving it some energy. Okay. But finally, when it escape out, the total energy will become zero. Sorry, the energy final will become zero, because when it is the minimum velocity na, so when it crosses the gravitation of earth, when it escapes the gravitation of earth, its velocity will become zero. So it does not have any kinetic energy, and we project the object at infinity. So u at infinity is also zero. In the previous case expression we have seen, which means the initial energy is equals to final energy, and final energy is being zero. So here applying conservation of mechanical energy. So kinetic energy initial, potential energy initial is equals to kinetic energy final plus potential energy final. अब देखो, ये एक्सप्रेशन कितना डिफरेंट है mgh वाले एक्सप्रेशन से, है ना? ये कितना डिफरेंट है. ऑल्दो यू कैन गेट द सेम mgh, आप सेम इसी से ही आ जाएगा. ठीक है. डू नॉट नीड टू वरी अबाउट इट, ये कैसे आया. ठीक है. But you should remember the gravitational potential energy is minus gm1 m2 upon r. Also remember this minus sign. Okay. We have projected this object with a velocity v. So kinetic energy will be 1 by 2 mv square. Initial potential energy is what? बताओ. Initial potential energy is what? Center of the earth से what is the distance? Center to center measure करेंगे. Minus G m e small m, let's say the mass of this particle is small m, divided by re plus h. किसी को कोई डाउट है इसमें? Equals to final kinetic is also zero, final potential is also zero. Clear? So if you just 1 by 2 mv square is equals to g m e m अपॉन आर ई प्लस एच, लिख सकते हैं इसे ऐसा. ठीक है. आर ई प्लस एच को मैं टोटल स्मॉल आर ई कंसिडर कर लेता हूँ, small r only, considering it is small r. And if someone having the language issue, like I am talking in Hindi also, so if someone is having like I'm not able to understand Hindi, not at all, so just let me know in the chat box. Okay. So that is the, that velocity is nothing but the escape velocity. ठीक है. When the final potential energy is being zero. ठीक है. इसे आप ऐसे भी याद रख सकते हो. ठीक है. So this is 0 0 means final potential energy is being zero. This is the concept of escape velocity. Escape velocity. Got it? Now just cancel out this mass. V square will become 2gme upon small r. So here we can say VE is equals to square root of 2g me upon r small r. Okay. But this is the general expression to calculate what? Calculate escape velocity. Now, if the particle, if the object, let's say, particle थोड़ा ज़्यादा small सा feel होता है ना. If the object is at the surface of Earth, then this small r will become RE only, because this H will vanish out. So VE is nothing but 2gme अपॉन आर ई. अब देखो इनमें से मुझे सब पता है, एम ई भी पता है, आर ई भी पता है, जी भी पता है. So if I just calculate, it will approximately coming out as 11.2 kilometer per second. So this much velocity you need to give a particular object to throw it out away from the earth gravitation, so that it would never return back on earth. ठीक है. So that particular velocity is escape velocity. क्लियर है सभी को? कोई डाउट है? किसी को कोई डाउट है भाई? एनी डाउट? एवरीवन? कौन कौन है अभी तक Yeah, Manish, you are saying something? Just give me a sec here. So we are back. Screen is visible to everyone. Screen is visible to everyone. Yes and no. Arey, just let me know, na. We have to finish this topic. Okay, just let me know. Okay, Kartika, thank you. Manish, you are saying something? Any kind of doubt you are having? Manish? So here we are doing this. Okay, Manish, thank you. Chalo, so we have done with this expression of escape velocity, which is root 2 GME upon RE. So let's just do a question based on that quickly. The ratio of masses and radii of the two planets are 2 by 3 and 4 is to 9. What is the ratio of the escape velocity at their surface? Just let me know the answer quickly within 1 minute. So you have 1 minute to solve this question. The expression of escape velocity is root GME upon R, 2 GME upon R. Okay, and not specifically ME. And this M is also like if you are calculating the escape velocity for Earth, so you have to consider the mass of Earth. If you are calculating the escape velocity from Moon, so you have to introduce the mass of Moon. Okay. Just let me know the answer. Your 14 guys are here. Just let me know the answer quickly within 1 minute. Within 1 minute, just let me know the answer. Okay, one has solved 2 by 3 times. Manish. सबसे पहले आंसर है मनीष का. देन इज दिस ओनली मनीष हैज आंसर्ड हियर. चलो वी विल डू इट. द रेशियो ऑफ मासेस इज m1 by m2. ठीक है. m1 by m2 is equals to 2 by 3. ठीक है. The ratio of radii is r1 by r2, which is given as 4 by 9. What about you, Epishika? You are not answering. ठीक है. And Kartika also. Just answer. This is a very easy peasy question. So VE1, we can say square root of 2g. G is universal constant. M1 upon R1. VE2 will become 2g M2 upon R2. Then the ratio of their escape velocity is V1 by V2 or VE1 by VE2. And it would be coming out as square root of M1 by M2. And it is inversely proportional to R1 by R2. So you will write as R2 by R. Now, M1 by M2 is 2 by 3. R2 by R1 is 9 by 4. So 2 to the 4, 3 3 is 9. So it is coming out as square root of 3 by 2. Got it? Very easy peasy question. If anyone has any kind of doubt, you can ask right now. Okay. Chalo. So this is the topic, gravitational potential. Very easy topic. So as we defined the gravitational field intensity. What do you mean by gravitational field intensity? So gravitational field intensity tells us about the amount of force that a particle is being experienced by the another particle at a specific point or a point in a space, which means indirectly what we are saying, that how much force is applied by a particle on the another particle will be measured in terms of gravitational intensity. So it is the gravitational intensity which will decide that how much amount of force that a particle will experience. Simple. In a similar way, we have just introduced a topic, gravitational potential energy. So this gravitational potential is nothing but the amount of gravitational potential energy of a system at that particular place only. Okay? For a unit mass. So gravitational potential, as you can see here, gravitational potential is at a point is defined as gravitational potential energy per unit mass of the particle placed at that point. Okay? So it is nothing but the work done in bringing a unit mass from infinity to the point in a given gravitational field. अब देखो इन्फिनिटी से किसी पॉइंट को किसी पर्टिकुलर पॉइंट पे ला रहे हैं, स्पेसिफिक डिफाइंड पॉइंट. तो इन्फिनिटी से यहाँ आने में देर इज सम डिस्प्लेसमेंट. ठीक है, there is some displacement. But what the heck here is, just try to understand the concept. Let's say m1 and m2 are two mass particle. M2 is at infinity initially, and we want m2 at this particular position at a separation of r. So from infinity to r, we have to grab this m2. हमने m2 को पकड़ा and we are keeping it here. Why we need to apply a force? Why we are doing the work done? Someone of you who are running their mind at a full pace can ask, "Ki sir, there is a attraction force in between them. Why we need to apply force? Why we have to do work? Because this is the automatic process. You just let the M1 and M2 open. M1 will attract M2. No, now this is the process here. Now this is the fact. Okay, very good, Epishika. Thank you so much. Okay. So this is the hack here, guys. Someone of you might ask this question, ki why we are applying force, why the work done is happening here. There is no need to do work at all. M1 can attract M2. So why this silly man is writing here that it is the work done, it is the work done bringing a unit mass from infinity to a point in a gravitational field. Gravitational field can apply the acceleration, but the answer is in the next word, without acceleration. We want that particle to come from infinity to a point, but we want that particle to be what? Stationary, like behaves like a stationary particle. Whenever you see between the journey of infinity to r, it will feels you like it is stationary at that point. ठीक है, क्लियर है? दैट इज वाई जीरो एक्सेलरेशन इज रिक्वायर्ड. और इसे अब ये देखो ऐसे भागना चाह रहा है, तो इसके लिए मुझे ऑपोजिट डायरेक्शन में से पकड़ के रखना पड़ेगा ना. ये ऐसे भागना चाह रहा है, तो मैं इसे ऐसे पकड़ के रखूंगा, ऑपोजिट डायरेक्शन में फोर्स लगाऊंगा. अब ये भाग तो रही है, लेकिन मेरा भी तो फोर्स लग रहा है, वर्क डन तो हो ही रहा है ऑपोजिट डायरेक्शन में. दैट इज वाई नेगेटिव टर्म्स विल बी देयर. पोटेंशियल एनर्जी का वर्क डन इज नेगेटिव ऑफ द वर्क डन बाय कंजर्वेटिव फोर्स. क्लियर है? इतना डीपली कोई नहीं जाएगा भैया, सीधा सीधा डेफिनेशन बताएंगे और आगे चलेंगे. क्लियर है? तो ट्राई टू अंडरस्टैंड व्हाट आई एम, टेक अ फील ऑफ इट. Now, someone might ask कि if this particle being accelerated, then what is the problem? ये problem ही problem है. If there is acceleration, without acceleration, it is moving like with negligible velocity. But if you give it acceleration, the velocity will increase. If velocity increase, there is an introduction of kinetic energy in the system. Okay. So the energy at this point from here to here, if you calculate potential energy and hee ha ha, you will do, okay, I have calculated it with the acceleration, then this is not the actual amount of देखो किसी दिन बच्चे नहीं आते, किसी दिन मेरे फोन के नेटवर्क नहीं आते, सॉरी वाईफाई के नेटवर्क नहीं आ रहे। ठीक है, कोई बात नहीं यार, क्या कर सकते हैं तो। सो वीबी माइनस वीए इज डिफाइंड एज यूबी माइनस यूवी डिवाइडेड बाई ए, पर यूनिट मास का पोटेंशियल डिफरेंस। तो यहाँ पे आप कह सकते हो कि वी पोटेंशियल डिफरेंस इज पोटेंशियल एनर्जी पर यूनिट मास, एंड gravitational field intensity is force per unit mass, gravitational force per unit mass. ठीक है, so if you want to elaborate on the relation between gravitational field and the potential, gravitational field intensity and potential. So let's say this is the uniform gravitational field intensity. ठीक है, I is in this direction. इसका मतलब क्या हुआ, if any particle is placed here it will experience a force in this direction. ठीक है, so suppose we have placed a particle of mass m, so force will be m into I vector. As particle is displaced from r to r plus dr here to here, work done by gravitational force will be f dot dr. And this is, देखो gravitational force is also acting in the same direction and displacement is also happening in the same direction, so angle between them will become zero. So here m I dot dr, as we know that du is equals to minus dw, work done is the negative of change in potential energy, then du is equals to minus mi dot dr, and I dot dr will be remaining because this will become potential. If you divide it by mass, so du by m will become what? Potential energy equals to minus I dr. These things you can utilize actually to calculate the potential, gravitational field intensity. The component, different component, so it is given as minus del v by del x. So in a question, you will get like this. ये I का क्वेश्चन है, I vector is given as k by x square. So you have to find the potential at point A. So we know that dv is equals to minus I dot dr. Okay, and here if r is measured in terms of x, so we will write it as I into dx. Put the value k by x square into dx. Now you have to calculate dv. Just integrate it from infinity to that particular point. Or here it is saying that potential to be zero at infinity. So we will take that from infinity at when x is at infinity, which means particle is at infinity, the potential will become zero. And for x is equals to a, let's say the potential will become v. So it is v minus 0 minus k. 1 upon x square का integration will be minus 1 upon x infinity to a minus k into minus 1 upon a plus 1 upon infinity. Now 1 upon infinity is nothing but 0. So it is coming out as v is equals to k by a at that particular point. Okay. Another type of question what will be like this. V is given as x square y square z, and z square x. So find the gravitational field intensity. So for that what we will do, we will calculate Ix, which is nothing but minus del v by del x. Differentiate this expression with respect to x, but this is the partial differentiation. और partial differentiation में क्या होता है, जिसके अबाउट आप डिफरेंशिएशन कर रहे हो, ठीक है, यू आर डूइंग द डिफरेंशिएशन विद रेस्पेक्ट टू एक्स, so only x will be variable, rest other will be treated as a constant. So if I just do it here, so first term is x square y. So y you need to treat as a constant. So only term being differentiated here is x square. So it will become 2x into y. Now this term does not contain x, so it will treat it as what? Constant. So differentiation of a constant is 0. Then differentiation of x is 1, but z square is constant, so z square into 1. So ix you have here is minus 2xy minus z square. Similarly, you need to calculate iy and then iz. Then finally, I vector will be ix I cap, iy j cap plus iz k cap. Okay, so this thing you need to remember. Now, if you Just allow me, I just introduce the continuous mass distribution. If point mass is not given, there is a continuation in mass. Okay, continuous bodies are given. So there are three type of variation. First is linear. This is linear. Second is planar, and third is what? Three-dimensional. So if the mass is distributed over a line, it would be linear mass distribution. Linear mass distribution. And for that, we apply that lambda is equals to mass per unit length, which is nothing but linear mass density. Okay. If the mass is distributed over this plane, so it will be a areal mass distribution. Okay. Areal mass distribution, when mass is distributed over an area. एरियल के साथ साथ इसे सरफेस मास डिस्ट्रीब्यूशन भी बोलते हैं. ठीक है, सरफेस मास distribution. So we define sigma here, which is nothing but mass per unit area. So it is nothing but surface mass density. Surface mass density. Similarly, if the mass is distributed over an entire volume, you can consider a sphere, solid sphere. So it will be volumetric mass distribution. So यहाँ पे rho is defined as mass per unit volume. Volume mass density. Okay. So this is it for today's class. If anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the class. Bye bye. Take care.